In this part of the video, we are going to look into how to use the interface and how to define your own interface. So let's take a look at our shape class. Our shape class says I'm going to implement two interfaces. You see, you can implement as many interfaces as you want. When you have more than one, you just put a comma between them. So using interfaces provide a way of multiple inheritance in Java. In Java, we have only single inheritance. Single inheritance means for a class, you can only have one parent. It's all single parents. You cannot have more than one parent. So that's called a single inheritance. And using interfaces make it possible for the class to have sort of multiple parents. Like in this class definition, we see it's a class shape, and we know shape extends object, although it didn't say that. But by default, if it doesn't have any parents, then object will be its parent. And it says implement two separate interfaces, and it could be more. And remember, when the class says I'm going to implement an interface, the class signs up a contract saying, okay, I'm going to provide implementation for every method inside those interfaces. But look at our class. Our class is an abstract class, so it could get away. It could say, I'm an abstract class, so okay, I choose not to implement some method defined in this one or some method defined in this one. You can get away, but your children cannot get away. So if your child class, your subclass, they are not abstract class, they're going to have to implement all the promises you did in your header, in your class header. So in our case, we say we want to implement comparable shape. So now let's take a look at the comparable shape. Remember last time we did that, we look up the comparable interface. There's a compare to method we have to implement. So we did it here. After we did it here, our child class, they don't have to do anything, but if they want to override it, they can always override it. But if they don't want to, they're alright, because we already provide the implementation here. So in our case, we just say, I want to compare area. Okay, so that's a natural ordering for shape, because I did it in comparable interface implementation. So now let's take a look at this one. We say, we have a collection of shapes. Remember, we have a collection of shapes in this list of shapes. And now I can do collections.sort shapes. I can do collections.sort shapes because shapes is a collection, a list of shape, and that shape implements comparable. So if a shape doesn't implement comparable, this line won't compile, because that's what required with the sorting method. Like the element has to implement comparable for this one to work. And now let's take a look at another one. Remember, we have another sorting method in collections class. That one says, okay, what if you don't want to use natural ordering? Then you can define your own ordering. We talked about this anonymous class last time. Let's review it one more time. So you want to sort the shapes using a new comparator. Remember, comparator is an interface. So you rarely do this. You only instantiate an interface when you have anonymous class, because a class is anonymous, so you have to use the interface name. You say new comparator of shape, and then the anonymous class definition, and you're trying to compare two shapes by their x coordinate, and you see you define and instantiate the class at the same time inside of this parameter list. That's what happened, and this semicolon belongs to this statement. Alright, so that's another way to sort your list of shapes, and the first way requires shape to implement individual shape to implement comparable interface. So now we have the idea about how to use an interface. When you use an interface, you say, I want to implement this one, and you sign up a contract. You have to provide implementation. If you don't provide implementation, you're alright because you're abstract class. So the subclasses, they have to provide implementation. And now let's take a look at this drawable interface. And this drawable interface is something we defined. So let's take a look at how to define the interface. Public interface drawable. You see, it's pretty simple. It's just void draw, and by default, every method inside an interface is public and abstract. So we don't have to put public abstract there. So in our interface, we only have a draw method. When you define the interface, it's very simple. Public interface, use that keyword, then just a bunch of method prototype, because you don't need to provide any implementations here. You only specify the contract for some classes to sign up. In our case, shape sign up the contract, say I want to implement you. Then shape has to implement a draw method, but shape says I don't know how to draw. I don't even know what kind of shape am I. But you're alright because you're abstract class. So now let's take a look at circle class. For circle class to be a concrete class, it has to implement the draw method. Otherwise, it won't even compile. Similarly, for rectangle class, and the rectangle class doesn't want to be abstract, then you have to provide the draw method here. So, and now let's take a look at test shape. Similarly, because of this draw method defined in the drawable interface, and because shape implement that interface, we can loop through the shapes and confidently invoke s.draw. It doesn't matter what kind of shape is that. They will all have the draw method because shape implement drawable interface. So again, you see dynamic bounding and polymorphism. So that's what we talk about. That's what about how to define the interface and how to implement the interface. Pretty much you sign up contract. And interface is a very powerful concept in Java, and we use interface a lot. Inheritance looks like a fun idea, but actually inheritance is such a fixed relationship. Like once you choose your parent, you cannot choose another parent. But interface is much more flexible. You can implement as many interfaces as you want. And when you use inheritance, there has to be a strong is a relationship. But the interface is like interface because it doesn't have to be the only one parent here. So let's take a look. When we say shape, rectangle is a shape, and also rectangle is drawable. So to be drawable, you just implement interface. You only implement whatever defined in drawable, and maybe there's some other interfaces you want to implement, then you qualify to be that one. So interface is for some kind of looser, not that a more loose relationship, not that tight like inheritance. And we have the slogan called program to the interface because we want to program to the contract, not the implementation. Because interfaces, they're just contract, pure contract. There's no implementation. You have to provide your own implementation. Okay, so what does we gain by implements drawable? When you implement an interface, like for example, we implement comparable and we implement drawable, what do we gain? So think about it now. Like now if I have a rectangle, the type information for that rectangle is very rich. Number one, it's a rectangle. Number two, it's a shape. Number three, it's comparable. Number four, it's drawable. Which means anywhere, if I need a rectangle, I can use it. Like for example, if I have a method that requires a rectangle parameter, you can use it. And if I have a shape requirement, you can use it. If the parameter says I require a comparable then you can use it. And if a parameter says I want a drawable object, then you can use a rectangle. So that's what you gain. So when you implement those interface, you are is a relationship like this shape class is drawable, this shape class is comparable. That's about interface. Thank you.